Okay, so this is the video for section 8.7. Mostly this is going to be just a bunch of terms and kind of describing things, so hopefully it doesn't get too dry. But really not a lot of examples to do. We'll do really a lot of the examples in class. I just want to get through all the definition stuff. So vectors. Vectors are basically you'll see them as arrows. Okay, that's kind of the way they look. They've got more to it than that, but that's the basic idea. It's just got kind of like a ray, but it stops because rays go on forever. So we'll use trig to find certain values in this. We'll find directions, and we'll talk about vectors in geometry and operations in a coordinate plane. So the first thing is this, a scalar. This is the first definition. Scalar is a quantity that is measured by a real number that describes the magnitude or size of a quantity. So like for instance, an easy scalar is like 7 when you talk about like 7 apples. You have 7 of them. It's a number that measures it. Magnitude has a little bit more complicated definition than that. Magnitude is really the size. Okay. Now, again, for us, real life at this point, it's always been like 10 feet, 10 miles, 80 meters. Those are all magnitudes. Well, whenever you're talking 2 or 3 dimensionally, the size becomes a little more complicated. So the one we're going to talk about then is vector. That's the last definition here. And a vector is a quantity that describes both a magnitude, which is an amount, okay, and a direction. So like you're going 6 left. That's an idea of a vector then. Now how do we draw that visually and how do we use that? That's what this section's about. But a magnitude is, again, just an amount, like 10 apples, 10 miles, 10 hours. But the vector throws the direction in there as well. So like 10 miles east, 10 miles north. And we'll talk about like 10 miles, 30 degrees of north. So we'll talk about certain things like that. Okay. So the next part definition-wise, okay, is a drawing. So again, a vector is like an arrow, okay, and it has two parts. It has the initial point A, okay, or the book calls it tail, and then it has its endpoint B, which is called the terminal point, or the tip. So tail and tip. But normally we call it initial point, we'll call it terminal point. And again, terminal means to end or to terminate, to stop. Okay. Another thing notation-wise too is that if you see a lowercase letter with this little half kind of arrow thing over it, that means you're also talking about a vector. Okay, so if you do the two-letter name, which is what we've got here, I've got A, B, capital A, capital B, you can do the same thing over it with that little weird arrow, or you can just give like a single lowercase name, lowercase a. But next definition, the magnitude of a vector is denoted by absolute value bars. And the absolute value really means the number's distance from 0 anyway, so that's what it's telling you, is how far away it is. And it is the length of the vector from its initial point to its terminal point. So that's what magnitude means for a vector. Just again, how long is it? What's its value? The vector itself is a length and a direction. But for us, if we just say what's the magnitude, we don't care about the direction, we just care about the length. Okay. So those are things that are difficult to get confused or easy to get confused with. Scalar is amount, a vector is a quantity size, or magnitude is a vector itself is a direction and a quantity. Okay. And then you have an initial point and a terminal point. Okay. All right, so other things that get confusing. Okay, the direction of a vector. Okay, the direction of a vector is the angle it forms with the horizontal. Okay, so there's one way, this is the first way to describe it, is to call it the angle that, from the horizontal. So in this case here, it's a 30-degree angle from the horizontal. Okay, so the direction of vector A is 30 degrees relative to the horizontal. So like a 30-degree angle of elevation almost, so to speak. The second way to describe it, okay, the second way here in that drawing is a measurement between 0 and 90 degrees east or west of a north-south line. So this one back here, I didn't have the north-south line. I could have drawn it in though. Let's say I did. Okay. I could talk about not only this direction here from the horizontal, but I could also talk about the direction here from the north-south line, okay, which we'll talk about in a second. So over here I can do that, and again it's this case 60 degrees, okay, east, because east is to the right, of the north line. And again, they say 60 degrees east of north. What that means is the north line, I'm 60 degrees east of it. And again, most of the time we'll be spending kind of talking more about the horizontal distance, but we will have to spend some time talking about the north-south distance. So the next definition, again, a lot of definitions here. Vectors can be represented on the coordinate plane, okay? And a vector is in standard position if its initial point is at the origin, okay? If its initial point is not at the origin, we're not in standard position. We're just somewhere out in space. Excuse me. Okay. Okay, in this position, a vector can be uniquely described by its terminal point, x comma y. So if we start at the origin, we can just say, yeah, you're at x, y, that's where the vector ends. Okay. Now, if you're not at the origin, or you could still do the same with the origin, but if you're not at the origin, if you're not a standard position vector, you have to use something called component form. And notice it looks a lot like you're doing parentheses, but it's not. It's different. You know, it's a different set of grouping symbols. And how component form works is it's two-part. Okay. It describes a vector in terms of a horizontal component x and a vertical component y. That's how it works. So it'd say x, y. So for this one here, if I wanted to describe this vector, p x y works as it's at the origin. But if I wanted to use component form, I would just say this. Whatever x and y are. Okay. Because of the fact that it means I'm gone right x units, up y units. And if x is positive, it means right. If y is positive, it means up. If x is negative, it means left. If y is negative, it means down. Just like an ordered pair. It just is not an ordered pair because we don't know where it's starting at necessarily. So here's an example. Here's an example. Let's look at the red vector first. Okay, it's starting at 0, -1, so it's not in standard form. It ends at 4, 1. So if I wanted to write this in component form, I'd have to figure out its horizontal and vertical, all those kind of changes. Well, here's how it works out. It makes a right triangle. There we go. And in order to do this, I had to go right 4 units, up 2. Well, then in vector form and component form, it would work out like this. Right is +4, 2 up +2. That's it. That's component form. Now I might be saying, well, what does that matter? Well, it's going to help us out here when we do our other stuff later on with magnitudes. But it doesn't care where we started at. It's just saying from this point here to this point here, I went right 4 up 2 units. Okay. Okay, so now what I'm going to have you do is just try to answer it on your own, what you think the blue one is. If it's wrong, don't worry. Just make a guess, you know, and then I'll explain the work in a second. Okay, so for the blue one, looking at this guy, we're going to go to get from P to Q, because again, P is the initial point, Q is the end point. I'm going to go left 2, and then I'm going to go down 4. That's how I get from P to Q. I go left 2, down 4. Again, always think of left to right first, then up and down second. So for the blue vector, okay, you should have said your vector is going to be left 2, which is -2, down 4, which is -4. Okay, so hopefully that's what you did say. If not, well, you know, hopefully it makes sense now. Okay, the last part of this then, this is the difficult part of this section, and I'm just going to walk through one example real quick on the homework. And then in class we'll spend a lot more time going through this, but I want you to at least kind of see the idea of this. So we want to find the magnitude and direction of the vector -4, -5. Now the book talks about using the distance formula to find the magnitude. We can do that. I'll show you an easy way on the next page. But the magnitude is the distance, so they use the distance formula to figure out how long this this vector is. Okay. The trickier part is figuring out the angle. Okay. Because again, what's going to happen is you're going to form a right triangle here. And then you have to use the side lengths of that triangle to find an angle. Plus, when they talk about the angle of direction, they mean starting from the positive x-axis, how did you go counterclockwise? Okay. So they got a 51-degree angle in here, but really it went 180 plus 51.3 degrees. So I know this is not going to make a lot of sense in this one because it's already done, but if you're comfortable reading through the book, this is what they did. The next page I'm going to show you how to work through it more slowly. Okay, so here we go. And we'll need our calculator for this, but we'll get to that in a little bit later. So find the magnitude and direction of the vector negative 1, 4. Right now, first thing you have to do is graph it. Okay, that's the first thing you have to do. You can graph it anywhere, but it's always easiest to graph it from the origin whenever we're doing magnitude and direction. So from here, that means I'm going to go left 1, up 4. So go left 1, up 1, 2, 3, 4. Okay, so here's the vector I'm talking about. Now, what I want is I want to know how far is this distance, and then here's the really tricky part. I want to know what is this angle, because that's the direction. How many degrees? And that's the hardest part about this. Because to find the magnitude, again, you could use the distance formula. That's what the book does. They use the point 0, 0, and negative 1, 4, and just did x minus x squared plus y minus y squared, threw in the graphing calculator. To be honest, I'm a little lazier than that even. If I've got it drawn out, here's how I prefer to do it. I know two sides. This side is 1, this side is 4. I'm looking for, and this is a right triangle more importantly, I'm looking for the hypotenuse. I just do the Pythagorean theorem. So for me, I would do 1 squared plus 4 squared equals, I don't know, let's call it m squared because it's magnitude, or you can call it c squared because it is the hypotenuse. So 1 is 1 squared, 1 squared is 1, 4 squared is 16, so 17 equals m squared. Take your square root, like 4.1 or something like that, but just to get a decimal approximation. Square root 17, 4.1, yeah, because nearest tenth is enough. So the magnitude, okay, the magnitude of vector p is 4.1. Okay, all right. So real quick, I'm going to pause it and say, does that make sense as to how I found that distance? So just say yes or no or a little or whatever. Okay, so now here's the trickiest part. I've got to find the angle of direction. And again, it's this angle here that I'm trying to find. Now, for me personally, because I've done this a lot of years, and you do this a lot when you take trigonometry. So next year in Algebra 2, if you take Algebra 2, you'll do this sum. If you've taken pre-calculus, you'll do this sum as well. I know personally that from here all the way around from here, this is 180 degrees. Okay. Now what I can do is I can find this angle pretty easily if I do some trig. And this 180 is going to come back in a second. So this is the opposite, the 4 is. This is the adjacent, the 1 is. So I'm going to use tangent of whatever that angle is, I'll call it x, equals 4 over 1. And then I'll use my calculator and do that inverse tangent to get x. Okay, so the inverse tangent of x, or inverse tangent of 4, oops, sorry, inverse tangent of 4, so second tangent of 4 over 1, which is just 4, is 75.96. I'm just going to say 76 degrees, just because that's what is x. Okay. Now again, here's the tricky part about this. This angle here is 76 degrees. I know all the way around here is 180. So from here to here will just be 180 minus the 76. I'm not going to make it there, which is 104 degrees. Okay. Now another way you could do this is you could try to find this angle right here and know that this is 90 and just add 90 to this little small angle right here, which you'll find out that this is 14 degrees right here, and then be 90 plus 14. But again, the way we do it in trig, so that's or in algebra 2 and in pre-calc, is we instead go to the 180. That's just tradition. So if it doesn't make as much sense to you this way, and you say, no, I can figure out this angle better, and that this is 14 degrees, and just do 90 plus 14, that's great. But the way it's done otherwise is it's done with, hey, find this angle and subtract it from 180. So we will definitely spend a lot more time with this in class. This is the more complicated stuff for the section, and then yeah, and then that'll be it. So you'll have two questions: one saying, how did this work out for you, and then one saying, who watched the video.